When a source of sound vibrates, it creates a periodic disturbance in the medium. This disturbance travels in form of waves. A sound wave travels in the form of a longitudinal wave, in which the direction of vibration and propagation of the sound is same. Let us see how a longitudinal wave looks and how is it represented by a wave. Consider this one particle. Now it is at its equilibrium or mean position. When the particle vibrates, it moves away from its mean position towards one extreme. It goes up to the maximum distance it can go and return to its mean position. Further, it moves towards the other extreme and similarly return back to the mean position again. When a layer of particles in a medium vibrates together, they transfer the energy to the next layer while they are moving to the extreme. This simultaneous vibration creates alternate high pressure and low pressure zones in the medium. The high pressure zone is created when many layers come together and each zone is called as compression. A low pressure zone is created when layers are farther away from each other and each zone is called as rarefaction. This zone together move further in space and the sound propagates. If we plot a graph of vibration of one particle, we get a wave. Let's see how. Here the x-axis represents the time of vibration and the y-axis represents the displacement of the particle from the mean position. Let's plot the graph simultaneously with the particle. As the particle moves towards one extreme, you see that the curve moves up, and as the particle comes back, the curve comes back down.